Arrhenius theory. This guy has said that acids, when dissolved in water, it gives the hydrogen ion. It gives or loses. And bases, when dissolved in water, it gives or loses the hydroxide ion. So basically, before that, we know that hydrogen ion is also called proton. But why? Why is it called a proton? Well, the hydrogen have one electron, one proton, and zero neutron. So when it loses one electron, only one proton is left. Thus, zero electron and one proton and zero neutron. So that's why it's called a proton, because it loses one electron and then only the proton is left. And also, let's not forget that that hydrogen can have or hold two electrons in its outermost shell. Let me just write this. Its outermost shell. This is the outermost shell of the electrons. It can hold up to 2 electrons. So, quick recap. Acids, when is ionized or when it is dissolved in water, it gives to the water or it loses the hydrogen ion, which is called also a proton. And bases, when it is ionized or when it dissolves in water, it tends to loses the hydroxide ion in the water. And chemist Arrhenius only cares about what happens inside the water. So limitations for the Arrhenius theory. The first one, only in water. It only happens in water. The second one, it doesn't state or describes why ammonia is base. The only basis in Arrhenius theory contains hydroxide ion at the end. The third one, it doesn't prove the transfer of a proton, which is, we know that from the Bronsted-Lowry, it's from the acids to the bases. In the last one, it doesn't contain the gaseous states. So, exam tip. Acids, they form from nonmetals. Group 17, the halogens, and some elements. And bases, metals. Hydroxide metals, the metallic oxides, and also the transmission metals that are in the middle of the periodic table. And I have listed some of the elements, some of the compounds that are acids that are bases based on the Arrhenius theory. So let's do some quick questions. Write the Arrhenius equation formula.